Okay guys, once more we are in the lead code question series, and today we are going to solve a problem that is called the missing number problem, but it's marked as easy, but actually it introduces a great pattern of coding problems that would solve medium and hard ones. That is called a cyclic sort pattern. So let's get right into it. Given an array containing indistinct numbers taken from 0, 1, 2 till n, find that one missing number from that array. So basically you're given an array from 0 to n, and that array uh, is of size n, and since it's of size n due to the pigeonhole principle, uh, whenever you are giving a number of objects that wouldn't be able to get contained in a number of containers, a at least one container would have more than one element in it. So um, our elements, or our object in that case, is from 0 to n, meaning that we have n plus 1 elements, and our array would be of size n. So by that idea, there is one more element that we couldn't hold in our containers, which is in our case our indexes or positions of that array. Because in arrays we can't put two elements in one container or one index unless it's a multi-dimensional array, which isn't the case in that question. So you immediately, whenever you are giving a range of positive integers, you immediately should think of a cyclic sort algorithm. So what is a cyclic sort algorithm? Well, since you are given numbers from 0 to n, and the array is of size n, well, actually, by knowing that, you have positions from 0 to n minus 1, or you have valid indexes from 0 to n minus 1. What if you are given a range of 0, 1, 2, 3, and that doesn't have anything to do with the problem at hand, but let's say you have a range of numbers from 0 to 3. Well, and the array is given as follows. So how can you sort that array in O of n time complexity? Well, the merge sort time complexity is O of n log n, so you can't use that, and there isn't actually a sorting algorithm that is O of n unless there is a special case. Well, our special case is that the range of numbers is equal to the positions of an array, is equal to the size of an array, of the array. So array is of size 4, and the range of numbers is, well, 4 numbers. So if we map each number to its correct index or its correct position, then it would be sorted. So let's say we are at 3. Well, if 3 is in its correct position, no, 3 is in index 0, so 0 is not equal to 3, so 3 is not in its correct position. So what we need to do is swap whatever is in index 3 with index 0 at our current situation, because we have the value 3, so we need to put 3 in its correct position. So what you do is go through the array, and at each position you validate that position, that the position is valid, meaning that the value in that position is equal to the index of that position. So by putting the value that is invalid in our case in its correct position, so it becomes like, well, now we swap the we swap the value 3 to its correct position and got the value in the correct position in the position that we are in. So now index 0 has 1, and the position 3 is now valid. So we do that again till the position that we are in, that we are on, is valid. So is 1 equal to 0? No, it's not. Okay, so we need to get 1 to its correct position or correct index in that array. So well, its correct index is 2, so we swap the values like we did before. So 1 becomes 2 and here it becomes 1. Okay, so in our current position, which is index 0, is 2 equal to 0? No, it's not. Okay, so we need to get 2 again. Our position is not valid, so we need to get 2 to its valid position. So we needed to get it to index 2. Okay, so we swap the values, and 2 now is in index 2 and 0 is at index 0. Okay, so now our position is valid. Our position contains the value 0 and it's at index 0, so it's valid. Okay, so go to the next position. Well, our value is 1 and its index is 1, so it's a valid position. Okay, go to the next position. So our position's value is 2 and it's at index 2. Well, it's valid. 3 and so on and so forth if the array contained more numbers or more integers. So basically what you have done is that you looped on positions rather than indexes, on the concept of positions rather than indexes or numbers. So what you just did is called a cyclic sort, because you cycle between the positions, going to the next position only if the position that you were on is valid, by putting the invalid number in that position onto its valid position using the index in case of an array. So that is cyclic sort. It only works if the numbers are distinct and the array size is equal to the range of numbers that are given, and the given numbers are positive and they are incrementing by 1 in the given range. So this is cyclic sort in its own, and it's pretty useless in its own because that special case doesn't happen most of the time. So reflecting that on the question at hand, well, what if you have 4 0 1 and 2? Well, let's say that the range of numbers you are given is from 0 to 4 and the missing number is 3. Well, how can you get to that answer from cyclic sort? Well, by doing the same but adding a little extra bit to your algorithm. Well, now let's see what happens using the algorithm we just explained at 4. Well, does 4 have a valid index? Well, that means does 4 has a position to be put in. So there isn't a valid index for 4 because an array of size 4 has indexes till index 3. So there is no index 4 for it. So what you need to add to your algorithm is that you, at each position, you loop on the concept of positions, but at each position you have to check if the element, the value you have in that invalid position it actually has a place to go, actually has a valid position to go. If it does, then correct that position by going if we have position 4, if we have index 4, then 4 would have to be put in the index 4, swapping the values like we did here. If not, if we don't have a valid position, we would just go to the next position and ignoring that position because we can't correct it, we can't validate it, we can't make it valid. So by going by that concept, let's go forward. So 4, we don't have index 4, so we have no options, we have nothing to do to correct that position, so we would go to the next position. So now we are at index 0. index 1 I mean, which has the value 0, which isn't correct. So we would correct that position by exchanging the number in the invalid position, which is in our case position 1, with the by moving the value which is 0 in its correct position. Its correct position is index 0, so we swap the values, so 0 would become at index 0 and now 1 has 4. Okay, so we do the same. We stay on position 1 until we are sure that it's valid. So at index 1, okay, is it a valid position? No, it's not, because 1 is not equal to 4. Okay, so does 4 have a position to go? Can we correct that position? No, we can't, so we would just ignore it. Okay, and now we are at position 2. Okay, does 2 have a correct value? Is it a valid position? No, it doesn't. Okay, so we would just do the same, correct the position by putting the value we have in its correct position. So now 4 is in 1 and 1 is in 2, so we would need to put 1, which is the position we are in its correct position, which is 1. So we would put 1 here and then get 4 here. And the same, we don't have any we don't move to the next position and until we are sure that it's correct. Well, is it correct? No, it's not valid, because 2 is not equal to 4, so we would need to correct the position. Well, do we have options? No, we don't. Okay, so we ignore that position and go here. Okay, so is 2 equal to 3? No, it's not. Okay, so swap 2 with its correct position, swap the value we have, correct the position we have by putting it in its correct position. So now we have 2 here and we have 4 here. Okay, do the same, we are in that position, we need to make sure that it's correct. Well, is it correct? No, it's not. Okay, so we have to go to the next position. Well, we don't. Okay, the loop terminates. Now what we have is 0, 1, 2, and 4 in indexes 0, 1, 2, and 3. Well, by intuition, the basic idea that we would need to do or implement now is, hey, validate the positions after we did everything we can to correct these positions, to correct what we have, correct positions with the numbers we already have. So we would loop on that array, the resulting array, and go, hey, is 0 equal to 0? Yup. 1 equal to 1? Yeah. 2 is equal to 2? Okay. Is 4 equal to 3? No, 4 isn't equal to 3. So basically, what we need to do now is ask ourselves, what happens when a position is not equal to the number, when an index at a position is not equal to the number or the value that is in that position? Well, it must means that we didn't have an option or a number to correct that position, and the loop terminated on that case, that there wasn't a position or there wasn't an option to correct that position. Well, that means that we didn't have the number 3. So by doing that, we made sure that that position wasn't capable of being corrected. So that means number 3 wasn't there, so that means that it is actually our missing number. So we solved the question using cyclic sort in O of n time in a linear complexity, and we would get to why it is a linear complexity later on. And we'd say when we solved it in O of 1 space, we didn't need a hash map, we didn't to validate lots of stuff using an extra space, and that actually is a requirement. Your algorithm should run a linear runtime complexity. Could you implement it using only constant extra space complexity? So we did the first part, and now we would just need to tackle another case before moving to the part that's why the complexity is actually O of n. So let's get the case that it was 0, 1, 2, and 3. Well, as you can see, let's say that it wasn't valid at the beginning, and this is the resulting array of after doing all of that, after doing that loop and fixing the array, correcting the positions. Let's say that this is the resulting array. Well, when we do the second loop, which is validating the position corresponding to the number it's in after the cyclic sort algorithm, well, we find out that all the positions are valid. So 0 is equal to 0, 1 is equal to 1, 2 is equal to 2, 3 is equal to 3. Well, what then? Well, what do we actually return? There is no missing number. So do we just return -1, or what do we return? At this moment, you should ask your interviewer, well, what do we do in that case? Do we return n, or do we return an error code like -1 or something like that? Well, in that problem, since it didn't give us a base case or a case at for what to do when that case happens, well, we should look at the input. Well, it's 0 to n. We are given a range of numbers from 0 to n, and we have an array of size n and n plus 1 elements. Let's say m plus 1 elements. N is the maximum number of that range, and it is equal to the size of the array, but they are the m plus 1 elements where m is equal to n. Okay, so if all the positions are valid, meaning like we have here, that means that from 0 to n minus 1, since n is equal to 4 in our case, because it's equal to the size of the array, size of the array is 4, and 0 to n minus 1 numbers or elements are valid. So that means that the missing number from the range, which is the input of 0 to n, is actually n. So at that case, we would just return n, which is equal to 4. Okay, so that's pretty much it. At that point, you would just write the pseudocode yourself and try to implement the algorithm yourself, as it's a pretty confusing one, so you shouldn't directly implement the code yourself. Since I already know it, since I have experience with it, I would just implement it directly. So what I need is an index, which is equal to 0 for now. Sorry. Which is equal to 0 for now, and a while loop, a normal while loop, for index less than nums.length. Well, at that point, what do we need? We need to say, hey, do we have a valid index for the position? Do we have a valid position for the number that we have? Well, how do we do that? We said that it would be valid, we would have a position if we have an index for it. Well, do we have an, how do we say that we have an index? How do we validate that we have an index for a specific number? Well, we just compare it with the length of the array. If nums index of nums is less than nums.length and index, the position, the value is equal to the index, and nums of index is equal to the index. Well, what we need to do is swap the values. So let's say temp is equal to 0. Well, temp now is equal to, we need to extract, like, okay, so let's consider the case that we have an array that has 3 elements, so 0, 1, and 2. Let's say here is 1 and here is 0. Well, we are at the first position. Well, is it correct? No, it's not. So we would need to exchange these two values. We need to put one in its correct position, and while doing so, we need to exchange the values in the process, during the process. Well, how do we do that? Well, here we are at nums of 0. Okay, the value is contained in nums of 0, nums of index, and we need to put it in, we need to get the value in nums of index, which is nums of 1, which is because nums of index now points to the value 1. Okay, and we need to get the value in nums of 1, which is nums of index. Okay, so we need to get that value before we could overwrite it with the value we have right now, which is nums of index. So to do that, and I know the code looks pretty confusing at the moment, but once you get used to it, it would be simple. So nums of index, we would get the value here, and we would change the value in nums of index to, well, nums of index. Why is that? Because nums of index is nums of 1, and we need to put 1 in it, which is nums of index. Okay, so now we would put in nums of index, which and index now is 0 in our case, so nums of 0 we would need to put in the value that was in nums of index, so it would contain the value temp. Okay, and else increment the index. Okay, so what we did here is that we just exchanged, so the else statement wouldn't get computed or wouldn't get executed because we did that. So once more, you have to concentrate on the idea that you have to validate your position. You have to validate that the position you are on is correct, or you don't have an option to exchange with before actually going to the next position. So what happens here is that we exchange the values, so now 0 is here and 1 is here, and we are still at position 0. We didn't increment the position. So now we would validate, okay, is 0 equal to its index, is nums of index which is equal to 0 equal to its index. Yes, this should be not equal to. Is it not equal? No, that's a false, so it would go to the index. It would go to the else, so it would increment the index. Okay, so this part is the cyclic sort algorithm. Basically what you need to do now is just for int I is equal to 0, I is less than nums.length plus I, you would just need to validate that the position is correct by just doing if I is equal to nums of I not equal to nums of I, which means that the position we are on, the value in that position isn't equal to the index, which means that the position couldn't be corrected because there was no number, that the number needed to correct that position wasn't present, so that is the missing number, so we would just return I. And for the case we have mentioned that the given input is from 0 to n and n is the missing one, we would just return n. Okay, so that should work. Let's run code. Sorry, we would return nums.length. Okay, so that works. Let's submit. Okay, so that works. Well, why is the and now the runtime is 1 millisecond faster than only 43% of the Java Online submissions for the missing number question. Well, why is that? Why isn't 100%? Well, the question could be solved using cyclic sort, but that doesn't mean that it is the best approach to solve this question. Actually, the best approach is using the fast pointer, slow pointer approach, but this is out of scope of the video we are doing, because the scope of the video is introducing to the cyclic sort pattern of coding question. Well, here this question, which is a hard question, is solved using the cyclic sort. Here it's solved using the cyclic sort, not the third one here pattern, which is the fast slow pointer pattern. So actually, knowing how to solve this problem using cyclic sort is much more better than solving it using the fast and slow pointer, because it would make the hard questions that are solved using the same pattern easier. So let's discuss the time complexity. Well, let's just clear this. Well, to get the time complexity of an algorithm, you should trace a worst case scenario of that algorithm, that question. So what is a worst case scenario of that question? Well, the worst case is that all the elements are in their incorrect position, or not in a valid position. So let's say 4, 2, 0, and 1. And also a worst case that there is actually a missing number. So 4, 2, 0, 1. Well, 0, 1, 2, 3, and I will fast forward the next bit so that you can see each iteration. I would draw each iteration, and I would number the number of I would write the number of iterations here, so you could get the idea of how many iterations are needed to solve the question. So let's get right into it. Okay, so it took 7 iterations to correct all the positions with all the options we have to make them valid, and it took 7 iterations. So what is the array size we have? Well, our array size is 4. Okay, so it took 4 plus 3. Well, what is 4 plus 3? Which is equal to 7. What is 4 plus 3? It's n plus n minus 1. So the complexity of the cyclic sort is of n plus n minus 1, which is equal to O of n, which is asymptotically equal to O of n. And then the other loop, which is here, is also O of n, so it's O of n plus O of n, which is also asymptotically equal to O of n. So it's a linear time complexity and a constant space complexity, because we didn't use any extra space. That's it for the cyclic sort algorithm. Thank you for watching, and I hope you like and subscribe